Okay, I guess everybody's coming back in. So before Bob starts, I wanted to make an announcement. Obviously, with Dr. Carell's outstanding presentation, there's been a lot of interest in getting copies of the slides. And so as when you registered, we have a copy of your email. So I've spoken to our folks here, and what we're going to do is we're going to send a follow-up email to everyone with a link where you can go onto that link, and we'll post the presentations there. So that way we don't have to do one-off kinds of things. So stay tuned after the event for a follow-up email from us, and then we'll have access to the slides. So with that, I'm going to turn it back over to Bob, who can take you through the next presentation. So Bob.
Thank you, Greg. Thank you. All right. So, I was debating on whether it should be BB and then BC, because he's a hard act to follow. Okay, so I'm going to talk about is climate having an impact on important systems that impact us. Okay. Bob was sort of going around the glacier, but I'm not going to beat around the glacier. I'm going to get right down to what's happening here and why it's happening. So, first of all, the period of hurricanes between 2006 and 2016, it was pretty quiet. We had a big active time in the early 2000s, and then it was quiet for a while. And then, in 2007, it started becoming active, and since then it's been moving right along here. 2017. So the story I'm going to tell you is about super warm ocean water, seawater, Sahara dust, explosive development cycles. I call it ED, so I just wanted to make sure that you don't get that confused. Record raining hurricanes and pinhole eyes. Okay, so and how the global climate is on all four of the above. And this looks like, go ahead. This doesn't look like the right one. It looks like the one that was loaded before, not the one that was loaded this morning. The reason I know it's climate, and then it said 4 after it. You see that 4 there? Climate 4 on all of the above. Well, anyway, that's okay. Okay, we'll just go. There's going to be a few typos, I'm sorry. Okay. None of them are X-rated, thank you. All right. So, what I like to talk about is how we sort of measure things so that we can keep the measurements in perspective. And one of the things is called ACE, is accumulated cyclone energy. And this is how we keep track of if hurricane seasons are above or below normal. But essentially, what we do is every 6 hours, we take the maximum wind speed in every storm, and we square it. And for, let's say, Hurricane Irma, when it started, every 6 hours, we keep track of that number. And at the end of its life, when it's gone, we add it together and we get a number. And that tells you what the accumulated cyclone energy is for that hurricane. And then in a hurricane season, if you have 10 storms, we add all 10 of those together, and that makes up how much energy was used for that season. And so that gives us a way to talk about, is this a big season, a small season, what kind of season is it? Hurricane Irma, of course, had the highest accumulated cyclone energy of any measured hurricane in the Atlantic Basin, for example. So that's why that was such a big storm. The average number for a whole season is 96. So don't worry about it. Just remember that number now. So what are the ingredients for super hurricane formation? Well, first, we need warm water, because that warm water is what the hurricanes suck the energy out of the water and convert it into wind and rain energy. Without that, hurricanes can't form. And the deeper and warmer that warm water is, under all other things being equal, the stronger the hurricane will be. So we like to see it, or don't like to see it, at a depth of about 200 feet. Also, wind shear is, what wind shear is as you go up in the atmosphere, if the winds are blowing harder up here than they are down here, it creates a shear because the wind speed increases with height. And that's not good for hurricanes because it sort of blows them off their eyes. So it closes their eyes, if you will. And the eye, of course, is what makes the hurricane such a unique thing. So very little wind shear is important. And then rapid cooling of temperatures with height, because when the temperature goes down as you go up and you raise air from the surface, it creates condensation. And when condensation happens, we get clouds, we get rain. And that's when the latent heat that's stored in the water, in the ocean, is converted from potential energy to kinetic energy, or energy of motion. And winds are really energy of motion. Okay, so this is also a derivative of warm water, is a thing called the loop current. And I want you to understand this, but it's a current that moves up from the Yucatan Peninsula and then out across the Florida Straits and merges with the jet stream. It's a very powerful force in the Gulf of Mexico. And you might notice that it sort of undulates and forms this, what we call loop. This is going to be important not only for my talk, but for some to come. Because this is the story of the red tide, too. Okay? And I don't know if you can see what happens, but by the time we get to step 4, we have these little eddies that break off in the Gulf of Mexico, super warm water. If you get a storm forming that happens to go over one of those eddies, all of that potential energy stored in the ocean gets sucked up into the hurricanes, and they go through ED, explosive development. So this is what it looks like. The bottom one is July 23rd of 2017, and that is the loop current. And you might note that it's right along the west continental shelf of Florida, which used to be a landmass, according to Bob, but is no longer. And then if you look at the one up there on 25 July 2018, a year later, you see that big blob of hot water. I was looking at this back in May and worried that we would have a major hurricane potentially in the Gulf in October, because I saw this in May. So there's something to this loop current. I also want to point out that in the top picture on the left is also an eddy, and in the bottom picture on the left, there's also that eddy that shifts. That's where Hurricane Harvey went, right over that eddy before it struck Houston last year. So compared to last year, this was a boring year in hurricanes. It was only normal. It was a normal hurricane year. We had 2 major hurricanes. They both hit the United States. So that's why we don't think it was normal. Florence was a Category 4, but when it hit the Carolinas, it was only a Category 2. Michael was a super Category 4, one more mile an hour, and it would have been a Category 5. And it went right over the loop current that we saw in May. So this is the paths of all the hurricanes in 2018. The green is when they're tropical storms. The yellow is when they're getting close to hurricane force. The red is when they're hurricane, Category 1 and 2. And then the purple is where they're super hurricanes. And you can see a lot of yellow and a few reds. But look at the southern Atlantic, where Hurricane Irma formed last year. Barely a hurricane day, the opposite of last year. The southern Atlantic was cold this year. It was hot last year. Unfortunately, the Gulf of Mexico was hot this year. So if we add up all of the accumulated cyclone energy for last year, it was 129. 90 is average, so slightly above average. Hurricane Irma and Maria together was more than 129 last year, just from those two storms. This was from 15 storms. So it is the right one. Thank you. So I just wanted to say the normal strikes by state in a normal hurricane year. The first column is the percentage of chance that any one of these states would have a hurricane in any one year. The second column is whether it would be a Category 3, 4, or 5, which is what we call a major hurricane. Take a look at Florida. 11%, 51% chance of a hurricane in any one year and a 20% chance of a major hurricane. We have 1,350 miles of shoreline in Florida. It's no wonder we have hurricanes. And we stick out into the Gulf of Mexico and the South Atlantic. So it's a favorable place for hurricanes. Okay, so some notable facts about our hurricane season is for the first time since 1997, there were no hurricanes in the tropical Atlantic. So it was an anomaly year on the low side, depending on where you were. The first 2 weeks of September were big, with 5 hurricanes going at one time. That's a record. During last year and this year, for the first time ever, we had 3 Category 4 storms hit the United States: Harvey, Irma, and Michael. Also, from May to August, it was really quiet. Nothing was going on. That was the story of the Sahara dust. The Sahara was kicking up dust storms that flowed across the Atlantic, and it ingested into the little hurricanes that were trying to form and killed them off. And that dust made the water cooler than it would have been because the sun wasn't coming through that dust cloud to warm the ocean. So dust is important, and we're going to find out why it's important for the red tide too. So significant wind shear in the Gulf existed early in the year, but the warm loop current was obvious. Here's a picture of the dust cloud coming off North Africa. It's so thick, you can't even see through it. And this was prevalent early in the hurricane season. You can see why a hurricane couldn't form out there. So Harvey and Florence were different kinds of storms. They were heavy rainmakers. They were moving slow. Why are hurricanes coming up to the coast and moving slow? We'll talk about that in a minute. Harvey, Irma, Michael, 3 Category 4s for the first time to hit the U.S. coast in a 2-year period. Never has happened before that we know of. September and October in both years were the hurricane season. Hurricane season runs from the end of May to the 1st of September, but the last 2 years, September and October. The ED cycles, Harvey, Irma, Maria, Jose, Florence, and Michael in the last 2 years, all had explosive development cycles. And what I mean by that is they went from little tropical storms to Category 4 or 5 storms within 24 to 36 hours. That's not normal. Pinhole eyes in all 5 storms and others that didn't hit anybody. What I mean by a pinhole eye, usually in a hurricane, an eye is 50 miles wide. These storms had eyes that in some cases were less than 10 miles wide at times. So I want to talk about now ice skaters. What do ice skaters and pinhole eyes have in common? Anybody have an idea? Okay, so when an ice skater starts to turn and do a spin, you notice how their arms are out like this? And then they go. And they start spinning faster. In the atmosphere, the same thing works. It's the conservation of angular momentum. If you shrink an eye with a hurricane surrounding it, what happens to the wind? It goes up. A pinhole eye is like a tornado on the ground, a big one. And it just wipes out everything in its path. Maybe the destruction isn't that far away from the center, but what you have when a hurricane strikes with a pinhole eye is essentially a large tornado on the ground. So that's why it's important. So the Sarasota magazine, and I have to say it's one of my favorite magazines, and they're here today, so I'm really going to butter them up. Based on our conference last year on Cuba and the Caribbean after the hurricanes, they invited me for an interview down in May and wanted to know about what the hurricane season might be for our neck of the woods in 2018. And these are the quotes from the article. Sarasota is more vulnerable to storms like Wilma or Charley that form in the Caribbean and enter the Gulf of Mexico, usually very early or late in the hurricane season. The most perilous time for us is the first 2 weeks of October. Even those storms really hit us here in Sarasota because of the way that Florida is tilted. The Coriolis effect of the earth turning underneath us, and the fact that northern Florida, it sticks out way more than we do, and they tend to get these storms. So we're sort of in a sweet spot here, but it only takes one. I want to say that. I think it was Susan Burns who asked me, does this mean we can breathe easy? And I said, hardly. I couldn't sleep during the days of Irma threatening us. All it takes is one. So this interview was in 2018 in May, and it was the cover story on the Sarasota magazine in July. And Charlie happened in October. Michael happened in October. The reason I was able to say something about it was this image that I looked at from the satellite before I did that interview. And there you see the loop current. The loop current was way up on the west coast of Florida, and I was worried about these eddies lasting all summer, and something coming out of the Yucatan, which is the favorable spot for hurricanes to form in October, and coming up over that loop current, and that's what happened. So was it a good forecast? Yeah, kind of. But it was based on the fact that the conditions that favor hurricanes was present even back in May, at least in part. Okay, so the first major hurricane was Florence. First, it sucked in Sahara dust early in its life cycle, and nothing really happened. And then the dust cleared, and within a day, it was a Category 4 storm. It struck North Carolina as a Category 2, but it stalled like Harvey did in Texas and created record rainfalls throughout the Carolinas. 36 inches versus 24 was the old record. 24 versus 18 in South Carolina. It's not just barely exceeding, but like unprecedented kinds of activity. So the word stalled has come up again. We'll get back to that. So stalling hurricanes, why is that happening? Well, Bob was showing the jet stream, and of course, that's at the root of all evil in weather, the jet stream. But he also showed on the global warming how the Arctic is warming up much faster. The north, our Arctic in this hemisphere, is warming up much faster than near the equator. So what happens is the temperature from the North Pole to the equator, the difference between those two is actually going down. And when the amount of the temperature difference goes down, then the atmosphere doesn't have to move as much to create equilibrium. The greater the temperature difference, the higher the wind. The less the temperature difference, the lower the wind. So following that idea, the jet streams are weaker than they used to be. And when they get weaker, it allows storms to penetrate further north and stall on coastlines and meander there. And that's the story of climate change. Hurricane Harvey and Hurricane Florence. Major hurricanes, but what we'll remember is not the wind, but the rain. This is Florence as it's coming into the United States, a beautiful nighttime picture with the city lights from all the major cities. I'm still awed every time I look at a picture of a hurricane from space, a galaxy in the ocean. Here's the path. You can see the blue, weak, and the red is where it's strong. And look at what happened when it hit North Carolina. All those little dots is where it stalled out. Michael, on the other hand, was an October to remember storm. The first Category 4 storm ever to hit the Florida Panhandle. It was the fourth highest sustained wind measured in U.S. history. It had the third lowest atmospheric pressure in U.S. history at 919 millibars. The normal is about 1,000 millibars. So 10% of the atmospheric pressure was gone in this storm, had been sucked right out of the storm. It was so strong. Now, this is really, really an interesting one. It was the lowest ever measured pressure in the world by an actual instrument is 905 millibars. April 22nd, 1989 in Australia. Michael was 919. It was just short of a world's record, low pressure. Over the loop current, pinhole eye, not a heavy rainer, wind and storm surge. Different animal. There's the path. From the Yucatan Peninsula, it just steadily gained strength and really reached maximum force as it was hitting the coast. A really, really scary situation because people who thought they were going to get a Category 1 or 2 ended up getting a Category 4. And what if that was a city with 5 or 10 million people in a metropolitan area? How do you get rid of that many people with such short notice? The answer is you don't. This is what it looked like on the radar as it hit the coast. The blue area in the middle is the pinhole eye. It was 12 miles wide when it hit. And the red on the radar is the eye wall where if you will, the tornado surrounding the eye. To the right of the eye, because of the movement of the storm, is where a huge storm surge rolled up. And because the sea level is higher now than it used to, it went inland further than it would have before. And this is what it looks like. This is a big data file. There's that eye as it comes in. And look at how it maintains itself all the way up into Georgia. Just unprecedented. It's pretty scary if you're in front of that, watching that coming at your house. There's the day, there's the sea surface temperature, and there's the path of the storm in green. It was just sucking energy all away. Here's another view of it. The pinhole eye. And watch how it maintains itself after it hits, like a tornado on the ground, all the way into Georgia. Did more damage in Georgia than any hurricane in U.S. history. Thank God it wasn't a big populated area. So what makes pinhole eyes? Hot water, weak vertical wind shear, low dust levels, all present last year and this year. This is Florence, when it had a pinhole eye and was a Category 4. Look at that. This is the first high-resolution satellite loop of a hurricane pinhole eye taken by NOAA 18, which is our present satellite now. That's the first one. I mean, that's an egg beater. And this is what the sea surface temperatures looked like when Irma was coming over. All red. Yes?
How many hundred tons of dust are in the air when you talk about that?
Oh.
Yes.
200? 60 to 200, Lenny says. Okay, he's the data analyst. So this is what Michael looked like. So two trends impacted by warming. One, more pinhole eyes, tornado-like concentration and damage and storm surge, Irma and Michael, and more slow-moving storms, record rains like Harvey and Florence. That's in 2 years, folks. So this is the hurricane forecast by the National Hurricane Center all through Michael's life. And you can see how the storm was predicted and how it moved and where it hit. It's kind of fun to watch it from the National Hurricane Center perspective. And here's Florence. It takes a second for this to, here we go. Notice how it was going to curve out to sea and then didn't. It took a jog to the left. And you could see the models wanted to take it left, and look at how it, look at that. Now watch what happens when it hits the coast. Slow, 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 slow. Look at that. Slow. That's why it rained. You see how long that meandered there? There were millions of chickens killed. Thank God there weren't people. So let's look at the losses. Irma, the damage in Florida, and Harvey, the damage in Texas. One wind and one flood. 150 to 200 billion dollars. I mean, that's getting into serious money. Florence, the damage to the Carolinas, 20 billion, and a loss of 3.4 million chickens and turkeys and 27,000 hogs. That's an agricultural problem. Michael, wind and storm surge, The damage to Florida and Georgia around 10 billion. 10 versus 200. Population center versus rural area. Here's Barbuda on the left before Irma went over. On the right, the day after. The forest is gone. Every leaf on every tree on that whole island, gone. Whoop. Mexico Beach, that's what it looked like before. And that's what it looked like after. Let me go back. You see that red house right there? Watch that. That's scary, folks. Houston, before and after, that's the same perspective.
Do you need to say anymore?
Florence, before and after. Before and after Florence. Okay, so let's wrap this up. Warmer sea surface temperatures trigger ED. Very fast development cycles the last 2 years. Pinhole eyes mean large tornado-like damage paths and huge storm surge to the right of the eye. Weaker jet streams mean stalling storms with big rain and floods. While the number of hurricanes may not be increasing, certainly their characteristics seem to be changing. So it's not necessarily we're going to have more hurricanes, but they're going to be different, and not different in a good way. This portends some serious evacuation issues when explosive development occurs near heavily populated coastlines. Florida has a problem. We can't get out with 21 million people here, all trying to get out at once. Are you not convinced yet? Well, this year had the third highest accumulated energy in the Northern Hemisphere. And in the Northern Hemisphere, there were 10 Category 5 storms, the second highest ever. So what about next year or this year? It's early, but so far, it looks like a normal hurricane season. About an 80 ACE is predicted, maybe close to normal. 8 to 11 named storms, 3 to 5 hurricanes, 1 or 2 major hurricanes. Sound familiar? As always, it just takes one. So I want to thank, that's it. I want to thank Dr. Phil Klotzbach. He is the Colorado State University hurricane forecaster and a very close friend of mine, as was his mentor, Bill Gray, who started this whole thing. And Bob and I spent many years with Bill, but his graduate student is now running the show, and he's a corker. So thank you very much. Who would like to ask questions? Right here.
With increased data science, are we able to predict better in terms of maybe months in advance rather than a week in advance in terms of upcoming hurricane? The reason I'm saying is that you have shown a picture about Houston. By the way, my house was next to St. Yaquino River. It is a $500,000 property, and I have beautiful pictures. The entire house is underwater. Anybody needs that picture? I'll be more than happy to share.
Okay. I don't know. He's got an affinity to water, this guy. So what I would say is the predictions that we make today are nothing like what they were when I started in this business. This is really a hopeful thing. It's gone from alchemy to chemistry. That's all I can tell you. We have a very, very high hit rate with long lead times on hurricane forecasting. And the error, while there is some, and it's important, is really small. I mean, Irma was forecast 10 days in advance here. And if we didn't have that, we could have never evacuated 6.6 million people left. It was the greatest human evacuation in the history of the world. So it's amazing. And that's our National Hurricane Center, which is right here in Florida.
And there was no warning for Harvey, by the way. Nobody asked to evacuate.
That's right. People didn't leave, but they knew it was coming. But nobody knew 60 inches of rain was coming. Okay, another question?
The house with the red roof that you pointed to, can you tell us, thank you, can you please tell us what allowed that house to stand and what was the cost versus normal construction?
Okay, so, boy, you set me up for that. I was trying to elicit that question. Wow, that was brilliant. Thank you. Okay, so here's the hope, right? In every tragedy, we learn something. In this tragedy, there were two gentlemen who decided they wanted to build a beautiful home on the shore right there, but they were worried about hurricanes. So they took the building codes and they increased the building codes that they had to do by 20%. And that house was right in the middle of a tornado, basically, coming on the beach. It's the only house standing. So what that says is just because we get struck by these major pinhole hurricanes doesn't mean we can't live here. But we have to be smart about how we live here. We have to do the right thing. We have to spend a little more money. According to the builder, it cost them about 20% more in building construction. But he has a bird's eye view of the Gulf of Mexico now, unobstructed. And PGT windows.
It seems to me that one of the largest stakeholders in all of this is the insurance industry. So besides raising rates, are they doing anything to help be a part of the solution of climate change?
Did I tell you to ask that question?
No.
Dave, would you please stand up? Dave is here, Dave McMahon. He's my insurance agent. And it's not like Allstate, where you're in good hands with Allstate. No. Dave is really looked at risk and climate change, and he's going to be one of our speakers this afternoon. So I don't want to steal his thunder, but that's Dave McMahon right there. Thank you for asking the question.
Yeah, and maybe for a brief, really, if you look at it from a construction standpoint, there's no question steps have been taken. I think what you'll find out, and I'll mention a little bit later this afternoon, the more difficult thing is flood. And I think what we have learned is that we categorize wind through Cat 1 through Cat 5. But the surge and the flood deserve so much attention. And flood is lagging behind because the government program is lagging behind. Sorry, Washington. Okay? But it is. It's a legacy program, and it's lagging behind. And the surge and the rain produced by Harvey are major concerns. That from a building standpoint, that from a mitigation standpoint, needs to catch up quickly. The rest of it is getting there, and we'll talk about that this afternoon.
Thanks, Dave.
Yeah, do you find that there are certain residential patterns that exacerbate flooding?
Is there what now?
Do you find that there are certain residential patterns that exacerbate flooding?
Well, yes. I mean, we have low-lying areas. Houston is a big bowl. We have New Orleans, which is below sea level. And, we've picked some really weird places to build major cities. Okay, so in the future, we don't want to do that again. It's not that you can't mitigate, because they can be mitigated, but it's a big expense. And in Houston, with 5.5 million people living there and all this concrete, the water has nowhere to go because the natural land that was there to absorb that rain is now concrete. So we have to think about that when we do our designs for the future. By the way, one of the largest art projects in the United States that's on the board right now is right here in Sarasota. Hundreds of million dollars are going to be spent on Bayfront Park. But I can tell you, they're designing it like there is going to be 6 feet of sea level rise. I don't think we're going to get that by 2100, but they're thinking about that. And that's the good news about this story. Lenny, do you want to? Can you wait until, just so everybody can hear?
As you'd expect, I've studied a lot of this stuff, and I agree with you about the high probability of being hit by a hurricane in Florida. But if you study the probability of being hit and where you are, one of the things that you find is that the probability of a major hurricane hit on the East Coast is far higher than on the West Coast. And if you go to the West Coast, it's higher south of Sarasota and higher north of Sarasota. So if you want to go to Florida and be in the safest place, this is the place to come. Can you comment on why we think that is?
That's a good question, and I can, actually. Okay, and I alluded to this earlier, but Atlantic hurricanes coming across the Atlantic generally don't come to West Florida. There's no way for them to really get here without going over land first, except Irma almost did that last year. There's 100 miles straight between Cuba and Florida, and that hurricane was 10 miles away from hitting that strait and coming right up the west coast of Florida. It was a 1 in 1,000 chance that could happen, and it almost did. But the reason we don't get strong Atlantic hurricanes here is because it has to go over land first. And when they go over land, they're not sucking energy out of the water, and they tend to weaken. We still get them, but by the time they get here, they're category 1 or 2. Okay? The Gulf of Mexico storms that come up from Yucatan generally come up along the west continental shelf, and because the way the Earth spins below the atmosphere, there's a Coriolis effect. It bears, the further north you go, the more the storms turn to the right. So when they go by Sarasota, they're heading north generally. By the time they get up to Apalachicola, they're heading northeast. And if you look at the path of Michael, it jogged to the right in the last 6 or 7 hours. It was heading due north toward Mobile, Alabama, but it took the jog to the northeast, and that's the natural flow of the atmosphere. So if you look at the probability statistics, the east coast of Florida has way more hurricanes, and the northwest coast of Florida has way more hurricanes than Sarasota does. We're geographically blessed here. But I want to go back to what I said before. It just takes one.
Hey, Bob.
Yes.
The MJO, the Matty-Juny Oscillation Index, which is a wave that travels around the globe every 90 days. I noticed between Irma, Michael, Harvey, and Florence was always in phase 2. Maybe you can explain to everybody what that is. Phase 2 or phase 3, which is a very active development phase. I think that was also part of these explosive storms, other than just the loop current. Do you think the MGO, I've just noticed, also is one of the reasons we had a very warm December when models were predicting a colder early winter? Anyway, do you think climate change has some effect on the MGO being this active the last few years and just maintaining itself? Because I know that's had a big effect on a lot of these hurricanes. And in fact, actually, it's cooling the Western Pacific right now. I'm sorry, the Western Pacific's actually very warm as well. The reason El Nino is not going to form, like many other forecast firms have been suggesting, so the oceans are warming, and actually in the Western Pacific near Australia, it's warming so much that it's going to kill any El Nino formation.
Right. So I have to acknowledge this gentleman here. Jim is a meteorologist. He owns his own weather company. And so when he starts talking about the Madden-Julian oscillation, MJO, by the way, Roll Madden was my, in the next office to me at NCAR when I was a scientist there, and he was doing all of that. So the answer I can tell you is, and maybe Bob has a different answer, I don't know. And you do? Oh, okay, he doesn't know either. It won't be the first time he trumped me. Oh, I didn't mean to say that.
Bob, we have a question over here. Bob? Bob?
Yes.
Over here.
Where? Oh, thank you.
With respect to Hurricane Michael, interested in you talking a little bit about storm surge. I live up in the Panhandle and drove through that area over the weekend, and you can certainly improve your home with building code, but I can tell you, I mean, there are rows of houses that were just washed away. There's a state park, St. Joe Peninsula State Park, that was the western end of it is breached. You can't get out there anymore. And it's going to have really significant effect on infrastructure, like Highway 98 at some point is going to have to be moved because of the continual erosion from increases in storm surge, not just from hurricanes, but from tropical storms and other weather events.
Right. So two things I'm going to say. One is, you're right. We can't mitigate everything. However, the state of Florida, being the 17th largest economy in the world, has no excuse for its #1 asset to be so severely eroded. They just aren't getting the job done on protecting the shorelines. And that's what I'm talking about. We got to get out of this mindset of blaming people. We can't do it because we can't say that climate is changing. It is changing. We can argue about why until the cows come home. But the fact is it's changing, and we need to get going. And we're not going to get going unless you guys say we got to get going, because you elect them. Wait a minute. Where are the people from Norway? Are you voting here?
Okay, Bob, I think we have time for one more. Just one more. All right.
Do you think that Sarasota's, I guess, immunity to hurricanes or such is influenced by having two large warm bodies of water, Charlotte Harbor and Tampa Bay?
Well, I will say this.
More warm water to attract and deflect
I'll tell you what, a complex coastline is really important, because when you have all these inlets, they do act as buffers to storm surge. They can concentrate storm surge in areas, but it's just like mangroves. When we let mangroves die, that's the natural buffer that protects the shoreline and holds it together. When you don't protect them, there's nothing to hold it together. Then a storm surge comes in and splits an island in half. It doesn't have to be that way, right? We can do stuff to make sure that we can't mitigate it all, but 90% of it can be mitigated. And the other thing about a complex shoreline is hurricanes like to hug them. There is a frictional effect by a complex shoreline. Take the archipelago of northern Cuba. Hurricane Irma got stuck in that archipelago just long enough to save our fat last year. Hadn't it done that, and you could see it wobbling from island to island. It was just amazing to see on the satellite picture. So the friction created by the land-sea interface creates sort of like a beeline for the hurricanes until it gets free of that. So yes, the complex shoreline is a factor. It has to be thought about, and our shoreline needs to be managed more and more. There's nothing natural about it anymore. There's 21 million people living here. The days of a natural shoreline are gone. By the way, 14 million lived here 10 years ago. It's explosive growth in Florida. Okay, now we're going to move right along. And this is an interesting story. and actually an inspirational story to me. Here we are in this incredible state of Florida with higher learning institutions, one of the largest tax bases in the whole United States and world, a beautiful shoreline with all of the houses and everything that we have on the shore. It would seem that we should be leading the world in climate change discussions and mitigation. But we're not. And one of the things that became clear to me as we were planning this is that we're missing a key component, and that is of integration. We have all of these assets, like I said about Steve Jobs. They're all on the table, but no group has showed up yet to organize those pieces of the puzzle. And that is the missing link to dealing with the climate situation. I hope we're going to remedy that. I think we can. And this man right here, when I heard him talking to me, said, "Oh my God, I feel like I'm talking myself." We actually have known each other because we're neighbors on Longboat Key. And by the way, so is Karen. And he said, "Well, I'm doing this presentation on red tide, and I'd like you to, come and look at it." So I said, "Sure." So I went down, this was months ago, and got the presentation, and he started showing me what he was doing. And it was interesting. He said, "I'm just looking at peer-reviewed science, and it exists in all of these places, but even the scientists in different places don't know that the stuff over here is available. They're still trying to discover things that we already know." So reinventing the wheel, this is very typical of the scientific mind. You do your research, and then you move on to the next piece, and somebody has to find it. It's not always published in a scientific journal. But Lenny is an engineer. He's a very good engineer, and he's an excellent data analyst. In fact, he worked for GE for 35 years on building jet engines. And then for 11 more years, he was a consultant to them. He's got a really nice house, so the consulting fees must be. We need to talk about that. Anyway, if you fly in a commercial airliner today, chances are it's one that's something he worked on at GE Engines. He's had a shadow on every single one of them. There's not many people that can say that kind of thing. And so he's an excellent engineer. And like every good scientist, which he is not, he has a curious mind. One of the most curious minds. So I'm just telling you, if there's a problem to solve and he gets interested in it, look out. So Len's going to talk about the red tide, and he's worked with a lot of people to put this together. And I think for the first time, you are going to hear, and I'm not going to say that everything he says is scientifically, statistically valid, because I really don't know myself. But I have never seen the pieces of the puzzle put together like this, and it's exactly what we need to do on the bigger picture. And so we're driving towards something here, and I want you to watch this. So without further ado, Lenny Landau. Thank you. You're going to love the puzzle. And could you turn off my mic?
Good morning, everybody.
I'm thrilled to be here. As Bob said, I've been working on this for some time, and I'm an engineer, I'm not a scientist. And I've been working with a bunch of scientists and reading lots of scientific reports, and I'm trying to figure out what's different about what I'm doing compared to what they're doing. So I'd like to just tell you that I this morning while eating breakfast, I got out my phone and I Googled difference between engineers and scientists. And what I found out was that engineers and scientists both are problem solvers. In fact, I've had some meetings with some of the scientists around here, and we get into arguments about whether or not they're trying to solve problems or not. But we approach things in different ways. Scientists conduct research for an understanding, and engineers work to build a solution. So engineers work with scientists to take the science and put the pieces together to solve problems. And that's what this is about. As Bob said, I live on Longboat Key. For those who aren't familiar, it's an island about 4 miles almost directly west of here. It has water all around it. It's got the Gulf on one side and Sarasota Bay on the other. And it's paradise. That's why I came here. About 3 years ago, and I'm going to give you the short version because we could spend 20 minutes talking about the long version about how I got here. But about 3 years ago, I decided I was going to do my own study on climate change. I was going to do exactly what Bob did. When I looked at his charts, my charts were very similar, not as good, but I focused on local data. I went and I got temperature data, I got sea level data. There's nothing about where did it come from and how do they measure the temperature of the earth and how do they do this. It was all on local data. And I went through this whole thing, spent several months doing it. And when I got done, it was clear. The thing that we had to be worried about was sea rise. Here I am on an island. We have some low-lying areas. The sea is coming up, and eventually this is going to be a problem. I live in an area where my elevation is high enough that it's not right there. And when you study it, you find out that it's probably decades away before it's going to really touch my feet. And one day I went and I had a meeting with somebody in Sarasota who was working on all of their abatements for climate change. And she had a report. And I brought it this morning just to show that it's real. And in the report, I went through the whole thing. I went to a meeting. One of my associates who was here came to me to the same meeting. And in the meeting, I got a copy of the report. And when I got home, I read it. And buried back in the report talked all about everything that was going on. And then there was a list of other potential impacts of climate change. Had a list of a whole bunch of things. And buried inside this list was red tide. I said, oh my God, because I've lived through red tide. I know about sea rise. It doesn't affect me right today. But red tide affects all of us today or tomorrow, okay? So I called her up and I said, I saw that on the list. Do you understand, does it really have an impact, and what is it? Because I figured if it really does, this is big time stuff. And what I was told was, we don't know. So that's what I got. Why doesn't this? Oh, well. Okay. Here's a picture of red tide. For those who aren't familiar, you see that dark stuff? That's red tide. So the first thing I decided to do was I was going to go research what red tide was and what we knew about it. I got literature. I went to meetings, and I went through all of this stuff. And when I got to the bottom line of all of this stuff, I found out one thing. People said you can't get rid of it. People said that applying solutions would be impossible. And the best advice was to stay away from the water. Is this... We'll get it. Okay. Then I picked up the local paper. And that's what the local paper said. True mitigation isn't getting rid of the algae. It's compensating businesses. Can you imagine that we're not going to do anything? We're going to pay people for dealing with this thing? And I took it pretty personally because I'm not a business. They weren't even going to pay me. So I concluded from all of this stuff, what's going on here? It's hopeless. Okay, we got it? It's hopeless. Can any of us deal with hopeless? This is me. So I said, if it's really hopeless, I either got to get out of Dodge or I got to understand what's going on. What on earth is going on? So here's where we're going to start. This is what we're going to talk about today. The first thing I said was, for me to do it, I had to ignore everything anybody told me. There was no room for what anybody told me, because if I listened, I was depressed and I couldn't make any progress. So I'm going to start knowing nothing. I said I had an empty brain. In engineering, we talk about a zero-based analysis. I started with nothing, and we're going to go through this through this. What's going on? What? Well, back up. Okay, back up. 1. Okay, now we're okay. Anyway, I know. So what we're going to talk about is what red tide is and what it does. I wanted to know. Then I'm going to talk about my approach. Why should you believe me? And then we're going to talk about influences, direct influences and indirect influences. When we're talking about science, there's indirect things that happen that aren't quite so clear. Then it'll sound kind of be a mush. It'll say, oh my God, why did he talk about all of that? I'll show you how it all fits together, and it's pretty simple, and then I'll wrap it up. And one way to look at this to get you a little bit comfortable before I get started is that if you had this on a scale, in the upper left-hand corner you would put hopeless, and in the bottom right you put hope, because that's where I gotta go, and that's where we're gonna go, okay? So, do you have another one? Okay, see that little guy up there? You're going to see him as I talk. When we talk about the influences, if climate change has an impact on something, he's going to show up. Okay? So when you see him, you'll know we're there, and I'll point him out. Okay, there he is. Next slide. Okay, so the first question is what is red tide? And across the top of this, it says, what is Florida red tide? We're going to talk about red tide that's only in Florida. But for the purpose of this presentation, I'll talk about red tide. But what we're talking about is Florida red tide. It's very clear that there's this algae. It's called Carena brevis. It is the only documented dinoflagellate, which is a single-celled algae, as you see on the chart, that causes 3 simultaneous things. It causes fish kills, it causes neurotoxic shellfish poisoning, and it causes human respiratory problems. There is no other algae in the world that does all 3 things. There are none. So when you hear about a red tide in Boston or someplace else, this is not it. It's different. This is our red tide. Click on the next one. I put some numbers on here to give you some magnitude of what was going on. Well, you think you got it? Okay. 127 dolphins killed, 213 manatees. This just came out of the paper earlier this week. 589 turtles. It's 571 tons of fish in Sarasota and Manatee County alone. That's over like 1,400,000 pounds of fish. This is a lot of fish at $29 a pound. It's a big loss. Okay. Here's the Gulf of Mexico. That little thing on the side, that's where we are. You need to understand that red tide is only in the Gulf of Mexico. And I'll tell you just a little word about the presentation. I gave a similar pitch to this not long ago. Every scientist I've talked about red tide, I asked, is it only in the Gulf of Mexico? And they said, yes. I gave the pitch, and somebody said, well, they had it in Miami. And so I had to change the slide, but it's correct. It originates in the Gulf of Mexico, okay? And we're going to talk later about how it gets from the Gulf of Mexico to the East Coast. But it's only in the Gulf, believe me, I've asked everybody, I've read all about it, it's only in the Gulf of Mexico. Okay, now what's the impact? It affects the environment, it smells, it looks terrible, it kills all this stuff. It affects public health. People don't want to come here. I was with somebody yesterday who told me how a friend had to leave town because of red tide. The economy is destroyed. If you were here when it was at worst, we go to restaurants and nobody was there. Everybody was canceling reservations for hotels and rooms and whatever. The guys who rent kayaks and take people fishing were just absolutely devastated. Property values were going to go no place if this went on. If somebody was at war with the state of Florida, and they wanted a weapon to come after us, it's clear that red tide would be perfect because red tide impacts everything. When it's here, it impacts everything. One of the things, while we feel the effects on the coast, there are things that go on internal to the state that affect it, but it affects everything. And I wanted to come here and give you a number and say that it cost us this year 50 million or 100, but I don't have a number, so I didn't want to put out a number that somebody's going to use. But everything winds up coming down to dollars and cents. It's going to cost us a lot. So here's my approach. I tried to be a scientist, to collect data, to look at water temperature and nitrogen and phosphorus, and so everything was in it and correlated. I found out I couldn't do it. And the other thing I found out is that if I was successful and I came to a meeting like this, the next day there would be all these reports about how I didn't know what I was talking about because I'm not a scientist. And I accept that. I'm not a scientist, I'm not an expert, and just so you know, I'm a student. I'm a student of this stuff, and I'm talking to you as a student, but I know a lot. And so this new approach, and one of my associates is here who convinced me that this was the only way to go, and that is something called peer review science. There's so much work that's gone on over the last 25 years on red tide, you wouldn't believe it. And what peer review science is stuff that was developed by people who were specialists in their field, reviewed by people who were specialists in the same field, and is used over and over. So when I tell you something, I didn't invent it. When he said he doesn't know if it's true, it's true. When I tell you, unless I tell you that it's coming out of my head, it's coming from scientists, and I'll show you what it is. If I wander off, I'll try and point out what it is. But peer-reviewed science, and this, by the way, this is not a thesis. It's not done in a way that when I have a quote, that I have a quote and the name of the person and where they're at. I'm not doing that. I want to make it so you can understand it. But when I show you something, that's what it is, and I'll give you an example in a minute. Okay. Bloom requirements. What does it take to have a Carena brevis bloom? The first thing is it's got to be present in the water. Okay? That's straightforward. It's got to be in the water. You see that little green thing up there? That's a piece of the puzzle. So as we go through this, when you see a piece of the puzzle, it means it's a piece of the puzzle. Okay? And in the end, we'll take all of the pieces and we'll put them together. The second thing is the environment. This Carena brevis likes a certain environment. It has a temperature requirement. It's got a salinity requirement. We're used to temperature. We're not used to PPT, but it means 25 to 35 means 35 grams to 1,000 grams of water, and it makes sunlight. It's pretty straightforward. And this is research. I mean, I didn't invent these numbers. This is the research. And then the other thing it needs is nutrients. Okay, so we normally talk. I'm used to talking about man-caused nutrients, but when you talk to scientists, they talk about anthropogenic nutrients. So when I say anthropogenic, this is what I'm talking about. And then you find out there's something called what I'm going to call bioavailable nitrogen. It likes nitrogen. But regular diatomic N2, it doesn't like. And you could have a lot of it, and you put this stuff in it, and it doesn't do anything. I thought it did, but it doesn't. So we'll talk about bioavailable nitrogen. Then the question that I ask, which seems simple, but it's not, is what is a bloom? What does it mean? And what I found out, and this is subtle, you're going to wonder, why am I saying this? But you'll get it in a little bit. It means that the growth is exceeding the loss. Okay, so if you have a bloom and you're in the middle of these ranges, what happens is it's growing more than it's dying. Okay? If you start to get out to the edges, you'll be losing more than you'll be growing. So when you get out to 90 degrees water temperature, we had this, it doesn't mean that it was all killed. It just means it's just not growing. We're not growing so fast. So it took me a while to figure out how do you use it, but that's the way you use it. So now I'm going to give you your first answer. You see the lower temperature up here? 59 degrees, okay? We talked about, you helped me with my presentation, about climate change. What you find out is the temperature is rising, but did you know that it's rising more in the winter than it is in the summer? That's a fact. And did you know that if you look at the average temperature and the maximum temperature, and then you look at the minimum temperature, that the minimum temperature at night is going up about twice as much as the temperature during the day, okay? And I got the data. I went and looked at the data. That's the way it is. So what does that mean? What it means is that we used to have red tide September, October, November. The water would get cold. The stuff would start to go away faster than we're getting it. And all of a sudden, we'd have December, January, all the people would come down, it'd be beautiful, everything is wonderful, and this is good. But what I'm going to tell you, you may want to write this down, is that red tide is impacted by climate change, not because the water is getting warmer, but because it isn't getting cold enough. Okay? This is pretty subtle. It's because it's not getting cold enough. And as a result, the red tide that we had last year came from 2017. The red tide that's out in the Gulf today is because it's coming from 2018. And here we are going into season with red tide out in the Gulf of Mexico. And this is, if anything that I've learned, this is very, very significant. Okay? Now, anthropogenic nutrient sources. Wastewater leaks, septic systems, flood control, runoff during rain and storms. You've heard about this, you've read about it. Included in here is something called urea. Everybody ever heard of urea? That's what urea is. It's in the waste products of humans, and it's also used in fertilizers. The most concentrated fertilizers have urea in it. So this is really, really bad stuff. In fact, there are people who believe that urea is like having, relative to this kind of stuff, it's like having a switch. And when you throw the switch, and we're going to talk about some other things, we're going to find out that it does some really bad stuff. So I spoke to my wife last night. I said, I have this terrific idea how we're going to solve the problem. We are going to require everybody going to the beach in Florida to wear diapers. Okay? She didn't think this was such a good idea. I told myself I wouldn't mention it, but I'm telling it to you because as we go through this thing, I want everybody to think about what I'm telling you, because we're trying to understand the problem so we can come up with a solution. That's not a good solution, but it's an example of the kind of things that we can think about. So the other thing you find out is that the impact of this anthropogenic nutrients and stuff is closer to shore. The closer you come to shore, the worse it is. The further you go out, the less we see it. So it's a piece of the puzzle. And if you read most stuff about this stuff, you find out that the anthropogenic nutrients are important. Okay, here's an article that appeared in last September in the New York Times. Said that behind California, Illinois, and Texas, Florida uses the most fertilizer. And oh, by the way, 30% of the population in Florida still uses septic systems. 2.6 million septic systems exist in the state of Florida today. There's a moving truck. What does it mean? 900 people are coming to Florida every day. Somebody asked me in this other pitch they said, well, how does that relate to anything else? Turns out that it's second to Texas, okay? And then when you go from there on, the numbers are all much less. So this is very significant. These people will keep coming if they think it's nice here. If it's not, they're part of the problem, and they're not going to come here anymore. Okay, so now we're through the easy part. I'm going to take a swig of water. This is what I call one-way causes. What that means is that you do them and it has an effect. It's like going down the road and where you're going is at the end of the road. So if we take away the sunlight, it'll go away. You won't have it. If the carena brevis isn't there, you won't have it. So this is pretty straightforward. But science isn't always like this. Science requires some things that are a little bit more complicated. And if you'll bear with me, we're going to talk about what else. And the what else is going to be some things that some of you have heard of, some of you have never heard of. And as I talk through it, you're going to say, why did he even talk about it? When you talk to some of the scientists, the science says that doesn't have anything to do with it. That one says, like I said, you got to start with zero. So we're going to talk about all of these things. And in the end, I'll show you how they all come together and why they're important. Trichodesmium. Is that a word that's familiar to you? It's a bacteria. It gets its energy from light, and it's found in Gulf waters. Now, this is an example of the way I'm going to present science. This is a quote, but it's not a quote. It's words that say that's been present before, during every red tide on the west coast of Florida. When I read it in the report, it didn't read exactly like that, but that's what it meant. I have 6 other quotes that I could present here that say that you get it relative, it's proportional, all kinds of stuff. But it's clear that trichodesmium is involved in the red tide cycle. However, to make it more interesting, what you find out is it's not an essential nutrient. Carena brevis doesn't eat this stuff. What essential means is that when the trichodesmium dies and falls to the bottom and it decays, then it becomes a nutrient. But while it's alive, it's of no use. Now we heard about the dust coming from Africa. Trichodesmium uses iron to grow and to convert nitrogen to a form, remember I said it takes a special form of nitrogen. So what you find out is that this dust is a piece of the puzzle. And where does it come from? It comes from Africa. This is a different satellite picture, shows it on June 28th of this year, shows the dust coming across the ocean. And somebody asked how much, there's the number again, 60 to 200 million tons of dust. And this started back in the 60s. There's this lake in the middle of Africa called Lake Chad. And because of climate change and dry weather and also over farming, the lake, which was about the size of Lake Erie, reduced to something that's about 5% of the size today. And as a result, we're getting these massive windstorms with the dust. And I'm talking about iron dust. The scientists who study dust tell you about all kinds of other things that are involved in this dust. In fact, I found there's a professor at the University of Miami who, I won't tell you his name, but he's referred to as Dr. Dust. Probably some of you know him. He's worked for 25 years only on dust. It's absolutely incredible. It's just, it's amazing. However, scientists have not been able to link Carena brevis blooms to red tide. And I didn't believe him. What? You mean to dust? To the dust. I didn't believe him. So I spent 2 weeks trying to take my Carena brevis counts and the dust measurements to put a story together that made sense. I couldn't do it. So why am I talking about it? I'll tell you in a minute. You'll see. This is okay. Now we're going to talk about Staphylococcus. It's another bacteria like trichodesmium that exists in the environment. Red tide can sustain itself
for long periods of time on this stuff, urea from land feeds this stuff, it thrives on it, and contrary to trichodesium, Carena brevis loves Xenococcus. So you say, geez, that's very important. However, when I talk to the scientists, I say, what can you tell me about Xenococcus? There's research. People spend a lot of money researching Xenococcus. Tell me about the Xenococcus that you saw along with this, and you find out we don't see it. So I said, well, in my field, I never accept yes for an answer. So that required some investigation to see why, even though it's supposed to bloom from it, why we didn't have it. And what you find out is that compared to trichodesium, it's a little dot compared to something that's great big. So if you look under a microscope to see it, it may be there, but you don't know it's there. And if nobody's looking for it, you don't know what it is. But we'll come back to Xenococcus. We talked about the shelf. You understand what that is. I'll give you a little warning. This next slide is interesting. A lot of what I did, like I said, I know nothing. I wanted to understand the Florida West Shelf. So I went on Google. I Googled the West Shelf, and then I wanted to look at pictures to see what the cross-section of the shelf was. Got this, you've probably seen it as a stream of pictures, and I started through it, and this is what I found. So when you do this kind of stuff, you have to use common sense. This is not a piece of the puzzle. Okay. Then you're going to hear about upwellings. Virtually everybody, all of the science will tell you about upwellings. I always heard about upwellings. I had no idea what an upwelling was, but it's very straightforward. If you have a wall, like the West Florida Shelf, and you have a current that runs into the side of it, it picks up nutrients that are on the bottom and bring them up to the top. This is pretty, and we've heard about upwellings. I'm saying, well, if upwellings are important, why aren't there people reporting? Well, why can't I find a picture of an upwelling? And what you find out is they don't necessarily come all the way up to the surface. There may be an upwelling that goes up some amount, but it doesn't come up to the surface. But it stirs everything up enough to get stuff to come up. So upwelling's part of the puzzle. We talked about the loop current. This is the same chart. It's the dominant feature in the Gulf of Mexico. But what Bob didn't tell you is that it's about 125 to 190 miles across. It reaches a speed of almost 4 miles an hour. The Gulf Stream gets up to about 5. So it's pretty significant. And it transports approximately 2 million cubic meters of water per second. 2 million cubic meters. 25 million cubic meters per second. This is huge. And if you read more about it, what you find out is the entire global input from rivers and streams going into all of the oceans is 1.2. So this is compared to anything coming out of a river, this is monumental. And if we could draw out the piece for this, we would find out that it's a very significant player in the game. Offshore circulation determines the nutrient state offshore, and science have been able to correlate 20 of the last 25 blooms looking at the loop current. It's well documented that the loop current is a major factor, so it gets its own piece. Now, let me tell you a little something about the loop current. Here's a picture of it. You can see how it comes up. This shows it in a northern position, and you can see the clockwise rotating eddy that goes along with it. And to answer the question about how does red tide get to the East Coast, the way it gets to the East Coast is that the loop current picks it up and brings it around to the East Coast. That's it. It starts in the Gulf of Mexico, and then it goes to the East Coast. There's variability in the loop current. How far it penetrates up into the Gulf, how wide it is. It may have a shape. It may have a big bulb on the top and be narrower on the bottom. And the location, how far it is off the coast. Right now it's way off the coast, but it moves around. The variability of the loop current is an important element of what's going on. I came up with this thought. I was studying this stuff, and I said, geez, what if the loop current crosses the shelf? Remember we talked about these upwellings? And what I found was there's research that says that upwellings in deep nutrient waters on the Florida shelf is influenced by the loop current. This depends on the current proximity to the West Florida shelf. So now this is starting to come together. Here's a picture of the loop current. I stuck on it. See that black circle? That's where the loop current was on June 15th. Our big red tide this year started in June. And this is, we'll move away from sun. I think that the loop current had something significant to do with when we had the big bloom this year. Okay, now you can take a big breath. We've been through it all. These are all of the pieces. And now I'm going to take a minute and show you how this all fits together. First piece, Carena brevis is present in waters, various locations and intensities. We got it? However, when it used to go away at the end of the year and be away, we would start out with something that was well diminished. If it doesn't go away and we have a bloom that's offshore that lasts for some period of time, this is more significant than it used to be. Trichodesium and Synococcus are present in the Gulf waters. Anthropogenic nutrients, iron dust from Africa is suspended in the water. Eventually, it all drops to the bottom. And we have, along with that, we have decaying bacteria and fish. When you hear about dead fish, it's important to clean up the dead fish because they go to the bottom and they generate nutrients for the red tide. Here we go. When the Gulf loop current is in the vicinity of the West Florida shelf, it creates upwellings. Okay, pieces come together. Trichodesium uses the iron to grow and to convert nitrogen into bioavailable nitrogen that feeds existing blooms and new blooms when the conditions are right. So we have an upwelling from and here we go. Offshore blooms are driven to the coast by winds and currents, and then what happens? Gets close to shore, nutrients, sewage and runoff and sediment feed the blooms, and Synococcus accelerate the bloom. So here we are. So if we think about this, I call this red tide bingo. If you take all of these things and you have a perfect storm, what happens? Bingo. We're in trouble. All right. So now we've been through it. So how does an engineer summarize this? Here's a red tide. I have a friend up the street who flies for one of the news stations in Tampa. I said, can you take me a picture? He took a picture, gave me this picture. The bloom we had this year was 20 miles wide, 150 miles long. This is just a little piece of it. So what does this all mean? What it means is it occurs naturally. We're not going to argue with that. However, climate change is enabling it to be here year-round, and increasing man-caused pollution is fueling it. So when you get all this together, that's where we are. And to get your attention, this is where we are. We're at a tipping point. This is us on the right. These things that are happening, and I talked about some of them, are causing this thing to be something that's going to be here. It's going to be here longer. It's going to last longer, and it's going to be a major problem. The way we've dealt with it in the past is we have a bloom, it goes away, people forget about it, that's it. It's, in my opinion, we're at a point where we have to do something. If we don't, and some of these things are going to be long-term, we have to do something now that we get dedicated, we have new leadership, whatever, we're going to have to do what needs to be done. Here's what the water should look like. If you go across that bridge, I live at the end of that bridge. Bob lives just down the street from that bridge. That's what it's supposed to look like. If you ask, well, what can you do? There are 3 levels, in my opinion, of what we can do in addressing red tide. We can't stop it. It's a natural thing. It's going to be, so we talk about control. I talk about control. Control has to do with seeing where it is before it becomes a bloom and taking some action to do something to keep it from becoming a big bloom. The second thing is mitigation. You have a bloom, keep it from getting giant. And the last thing is cleanup. Cleanup is something that you can use in a canal or a basin to clean up small amounts of water, but it's not what we're going to use to stop red tide. Red tide can be minimized, we'll call this mitigation, by reducing man-caused pollution. That's it. You've read about that all over. That's what it's going to take. And when you study this stuff, you find out that there is no downside to it. I mean, it's all good. You do it, everything looks beautiful, the plants thrive, the fish thrive, the industry thrives, tourism thrives, it's all good. And I'm not going to spend any time here today, but one of the things we know is that Chesapeake Bay is the most studied body of water in the world. There's no other body that's been studied more than Chesapeake Bay. They've had a problem they've been addressing for 60 years. In the last 20, they found a way to address it. We ought to be doing the same thing. You can Google clean up at Chesapeake Bay because I don't have time to talk about it, but it's an approach that we're right now pushing. Reduce the iron dust from Africa? That sounds crazy. How are we going to do it? And I had all kinds of ideas about spraying stuff on it, but what I found out was that in the 80s, the government came up with a way to refill the lake, and it was rejected. And on February of this year, the Chad government approved a plan and had funding to refill the lake. Isn't that crazy? And you say, well, geez, it's windy and it's dry. Where's it? It comes from a river that's about 150 miles away, and they understand it. It'll help farming. It'll help the environment. It'll help everything. So they're starting that. I'm not suggesting we do anything for it, but this is what we got. However, we need to stop the toxic bloom. That's really where we got to go. We have many of the people. Whenever you read a report on any of this stuff, there are 20 to 50 references. There's lots of stuff. The answers probably reside within the existing, but there's nobody looking at putting it all together. Just like Bob said, the challenge is complete the puzzle. To look at what pieces you have, what you know, what you don't have, and go out and change it. Okay? I'll tell you, I forgot to mention one thing. I talked about all of the problems that red tide caused and what the impact was. There's one good impact. Does anybody know what it is? Traffic. You got it. I didn't want to forget that because it does reduce traffic. So, just to end, the message is that it's here. We can understand it. We understand it. If we clean up the water, that'll have a significant effect. If we really get ourselves focused, and I'm talking about the problem we have is we got this university, that university, we got Moat, we have Florida Fish and Wildlife. Everybody's working on stuff, but there doesn't, from where I'm sitting, seem to be any place that's pulling it all together. We need to have a direction, a director, and get all the right pieces working and bring it together. So with that, if anybody's got any questions, I'd be happy to take your questions. There's one in the back. Your time is up.
So sorry if you mentioned this and I just didn't hear it. So there was actually some mid-2000s research from NASA that I found interesting and relevant and actually sort of as a connection to things that Bob was talking about, Bob Bunting. Basically, it's that an active Florida hurricane season also contributes to red tide because when we see additional fresh water dumped on the state, right, from a hurricane, it's going to increase the amount of runoff, right? So we're going to have increased anthropogenic effects, basically. And in addition, it's also going to affect the salinity of the water. right, as well. And so those are both things that could feed into K. brevis. So I'm just curious if you had encountered that in your research, and then I believe this research was then, the study was rerun in 2018 after Irma came through. So
I'll tell you, I didn't mention it because I got too many things to talk about. There is research that shows that climate change is going to reduce the salinity of the oceans. I don't see it as being a major player here right now. As far as hurricanes are concerned, I've studied hurricanes and tried to understand what the impact is. Most people talk about a hurricane after a red tide and it's going to break it up. Everything I've read says that that's not the case. That we may have it, it'll break it up. For some reason, we don't seem to see it. That's what I've seen.
This is a bit of a far out question, but in all your digging in the literature, did you notice any papers that dealt with species that actually consume red tide? I mean, it's toxic to just about everything, but everything that's toxic, there's something out there somewhere that eats it for breakfast. Do you know?
Thank you. This is something we have to learn about. When I talked about we got to get rid of the toxic bloom, I didn't say get rid of Corona brevis, did I? Or what I'm saying is we either got to get rid of it or we got to stop it from being toxic. And how do we do it? We don't know. But it's out. These things you're talking about, if they're out there, what are there, and can they be used? I don't know.
Yeah, just in other words, we might seed those beds with some species that consumes red tide. Maybe creating a new problem in the course of that, too.
Hi, I have a question. Does anybody in the audience know, is Sarasota and Manatee County still issuing permits for septic tanks? Because I just sit in my family room and I think about the septic and all the dumps going everywhere and the lack of maintenance on them and kind of what we're doing in Sarasota and Manatee to help mitigate some of that. Okay. The other thing is, does anybody know if Sarasota has a comprehensive plan for sewer? Because it seems every 6 months there is a toxic waste dump in the bay. And I sit in my family room and I just stew about this thinking, as an average mom, what in the heck are we doing here? And what are our leaders doing? Thank you.
Let me just address that one way. I get concerned when I talk about this because I live in Sarasota County, Manatee County is here. Believe it or not, in the last 10 years, Sarasota and Manatee County have spent over $500 million addressing this problem. They've reduced the number of sewage, where I wrote it down, sewage systems from, where did it go? And anyway, they've had a significant program. 60% of the septic systems have been removed. They have limits. We have restraints on when you can put down fertilizer. All of this stuff is going on. These things happen, but that's what has to happen. Is we need to stop these things. I know exactly what you're talking about. Ed.
I'd like to address your question, ma'am, on the sewage dumps. So Lenny pointed out that urea nitrogen, or urea, is a fundamental feeding of Synechococcus. So Synechococcus is a cyanobacteria. It's a green algae, naturally occurring. So when we get a lot of your extra urea nitrogen from a sewage spill, it creates more Synechococcus. Corenia brevis happens to feed on the cyanobacteria. It uses it as an energy source. So every time we have one of these sewage dumps that you're reading about, you should be incensed with the local municipality, the county or the city, that has allowed such a travesty to be committed against our environment. That is one of the primary recent causes of the escalation of the red tide blooms we're seeing. If we stop the sewage dumps, the septic tank leaks, the urea nitrogen exacerbation will stop this cyanobacteria. It won't go away completely. And the red tide is naturally occurring. It's always going to be there. But if we stop the pollution of the urea, we'll stop the cyanobacteria. So keep doing what you're doing and write your county municipalities, your government, and have the sewage dumps and the septic tank leaks stop.
Yeah. And the other thing is, it's not just because we live in Sarasota and we're near the water. It comes from inland as well. So we got to be concerned not just about here. And it may be a bigger problem coming from places that aren't close to here than the problem that we have here.
Lenny, thank you. So we have now gone from global to local on climate change. We haven't talked about mitigating, but there's some really interesting ideas. Florida, being the 17th largest nation in the world economically, could help Chad fill their lake, right? Why is that a foreign idea? We live in a global climate change. Florida is the 17th largest nation in the world, if it were one, from an economic point of view. Why can't Florida help Chad fill their lake? It would help our economy. That's just one example of an idea for mitigation. It sounds wild, and maybe it wasn't appropriate in the past, but maybe now it is. And so those are the kinds of things we can move forward to. Finally, I want to say is that Lenny shows why there's a missing piece. He's a person. He's a very smart person. No institution, no function in the state of Florida or in the United States that I know of is integrating these pieces together into a common picture. Lenny was able to do it, not being a scientist. He's putting the picture together. That is what is missing, and that's what we need to fix. And now David. David is going to talk about our panel. And I think, yeah.
Are we good? Yeah. We have 16 minutes to do a 45-minute panel. So we're gonna suspend the rules and do it a little differently. Lenny, can you join us, please? Let me, well, there's more this afternoon. So while Lenny comes up and everybody gets in a seat, let me ask two questions of this group. How many in this room either know or think they had a respiratory impact or an effect from red tide? Raise your hand.
Wow. Oh,
now, I know in some cases, thank you. I know in some cases, there are people in this room who saw physicians in the north for pulmonary care and reported to me that when you go from Florida, red tide, to the north, the pulmonologist doesn't think to ask you about red tide. Look at the constituency of all the hands that went up.
It's incredible.
Next question. How many in this room either live in permanently or temporarily, if you're a visitor, a dwelling in evacuation zone A or B or 1 or 2? Raise your hand. That's a constituency. Thank you. I have 3 questions because we have such a short amount of time. Bob Bunting, 3 minutes. Storm surge, we were going to get it, we didn't get it. What happened, what didn't happen? Quick lesson on storm surge.
Well, we actually did get a storm surge from Hurricane Michael. As it went by, even though it was 150 miles off the coast, the low pressure was so low, 919 millibars. It was not quite that low at the time it passed us. But the weight of the earth on the sea was released by 10%. And when that weight was released, the sea rose. That's what helps create the storm surge. You don't have to have a direct hit to get it. We had a glancing blow, but on Longboat Key, there was a 3-foot high storm surge that literally came right over the top of the beach. It was only there for a very short time, and it receded very quickly. But it surprised a lot of people that here's this hurricane that's not going to hit us, but because it was a record low pressure, the storm, the pressure was released from the surface of the water, and the water rose, and then it washed ashore as it went by. I thank God we didn't have a direct hit.
Outlook for storm surge for the next round.
So the outlook for storm surge is that because the sea level is gradually rising, right now it's rising in our area about an inch every 8 years. It's not catastrophic, but it's still a factor. Every time it rises a little bit, the storm surge on top of it penetrates inland more because we have a very flat surface coming into Florida. It doesn't rise that much. So even 6 inches of sea level rise will mean when a hurricane comes by, the water that would have been absorbed before will come into the coast in a bigger way. So rather than being inundated permanently, I think that's really more of a problem than, we're all going to drown. And that's why I'm saying we should be focused on the things that are going to impact us in the next 50 years, 20 years. Because it's in our own best interest to deal with this ourselves. We're not talking about our kids, we're talking about us.
I have a question for Lenny. You saw all the hands go up on respiratory response. You're an engineer. That's how you saw the red tide. You gave us a wonderful narrative on red tide. How do you see bridging red tide engineering to the medical side to form a coalition, seeing all the constituents right in this room? How would you do it? You have 30 seconds.
Like Bob said earlier, the more people this affects, and their outrage about what's happening is what's going to drive it. I'm a biker, and I'm a fisherman, and I'm a walker, and you don't want to be here when this happens. And then you start reading about the diseases and things that people that it affects. It's awful. What can you do about it? It's just what we've talked about. We got to reduce the pollution to mitigate it, and then we got to go find a solution to eventually stop it. One thing I didn't mention is that if we were to clean up everything, we had a program, got it all cleaned up. What the scientists will tell you, it'll take 3 to 4 years before we start to see an impact of it. So this is something we got to dedicate ourselves to, understanding it's not going to change overnight, but it's a long-term process that we need to go through. And I don't know that answers your question, but that's what you get.
It's a good start. Bob. Yeah. You came here 36 hours ago from a little different climate. You've been all over the world. You've dedicated your professional life to what we saw in that marvelous presentation. How do you see bridging the local, the regional, and the global? The Global Interdependence Center focuses on ways to do that, and we are very open to any recommendation you could make to create that bridge. What do you see? What's your vision?
I'm going to speak. I think I'm on the air, but I'm not. It's all right. Here we go. Lenny just told us how to do it. What I hear you saying, Lenny, is you first got to know. Second, you got to assess that knowing, that detailed knowledge you got together. Then you got to begin to plan based on that, and the ultimate, you got to act, okay? That's what I heard Lenny say when he was all done. So what are the ingredients? I see there are 4 nouns of the letter E: energy, environment, economics, and education, okay? Those 4 things are all in the same fishbowl, all swimming around, talking together, but they have to be connected. You need a verb to make it happen. First you got to do is you got to integrate that knowledge, the connectedness. You saw him do it beautifully. The second E is you got to be able to innovate, to be creative about how you might connect those sorts of things. Third thing, you got to aspire. And fourth thing, we have to invest. So those are 4 E's and the 4 I's. Let me give you a couple examples. When we did a big study some years ago, I got a phone call from NASA and said, we're going to continue to build this whole thing over there at Cape Canaveral. Is that a good idea, given what you told us about sea level and all? We spent 2 years working with them, and they decided, based on that knowledge, that a time scale of 20, 30 years was okay, and they would do it. But I think you all know the back plan is to move that in time. So they do it with planning. Oh, sorry. I thought I was on the air again. Panama Canal, as you know, it was redone. They had the same problem. And they went through what I'll call 4 Lennies, you know?
4 Lennies.
The 4 Lennies are to know, to assess, to plan, and act. And I really appreciate it. Lenny, what you don't know, I started my whole career with General Electric. And I had responsibility at a research lab to develop all the things necessary to get the B-52 bomber engines certified, and to work with the General Electric company that took me from my beginning in engineering into your company, but climate change came and got me. I think that gives you a similar, I really do think Lenny's got the plan. We've got the ingredients of it. We got to deal with energy issues. We got to deal with environmental issues. We got to deal with our economics, and underpinning. Thank you, Chancellor. We're going to have to do a better job with the education.
Thank you. We have time, but it must be very brief. 20-second question, please.
Okay. I'm not a scientist. I don't work in the science field. I work in economics, international business, and entrepreneurship. What I see is incubator. Why not build an incubator here in Sarasota, which is what we call a business venue for entrepreneurship? Put the spoken wheel in place. I would think that the hotel management business would be very interested in helping to sponsor and finance an incubator. Bring the people, including entrepreneurs in this area. Bring in the SBDC, the SBA, which has the money and the opportunity and the connection to the government. Bring in the scientists. Bring in the people who count, and you have an incubator. The host, which would finance most of that, would be the hospitality industry.
You've surfaced a great idea. We cannot address it between now and lunch 6 minutes from now, but it's a terrific idea, and it was heard by the chancellor of this university and this panel. One more question, please. Natalie.
Thank you. Since we're talking ideas, I'll put another one out there. I'm in the municipal finance business, and I had a conversation yesterday with a young startup company out in California, which has a very different problem of wildfires, and it's called Blue Forest Conservation. And what they have done is they have signed contracts with stakeholders, which is what we're talking about here. They pulled it together and sold a bond that investors bought, and they are now, and then they have an implementer, which is the Forest Health Restoration Company that is going to clear and clean a patch of forest in the state of California. So some of the stakeholders were the forestry, the agency, the state, and the local electric company.
This is a model that I think is extremely exciting and has a lot of potential, thinking of all the restaurants in Florida, thinking of all of the businesses that were harmed by the tide, and so on and so forth, are all stakeholders that can be pooled together into a financing that investors can buy and move forward. So that's just
Thank you,
another-
Natalie. Another good suggestion. Use her. 7 seconds.
I wouldn't even get there in 7 seconds.
From my point from Norway, working with the same issues, you have a fantastic advantage here in order to create the motivation. You have the fact that red tide, if that become a year-long event, is going to destroy this society. It's going to destroy the possibility for the medical profession, for the restaurants, the whole yang. So you are in a state, it must be said carefully and intelligently, but I think what you have is a question of its continued existence of a quite marvelous society. And that is worth fighting for.
Hear, hear.
Bravo. Thank you, sir. Because of the limitations of time, let me just housekeep a couple of things and end with a story. First of all, there are more Zika pamphlets. We found them in a box under the table. They're on top of the table now. Secondly, the slides that you saw are available, public, can be used. They will be on the university website. They will be on the Global Interdependence Center website. They're available. Use them. Send them to your friends. Do all of that. Please help spread a word. Third, years ago, the Global Interdependence Center had a conference similar to this at a small university in Philadelphia. From that conference came a 5-continent, 12-city, worldwide discussion on food, hunger, water, and security. I personally had a little involvement in that one. So it's amazing what you can do when you are inspired, and we certainly have been inspired by 3 wonderful speakers this morning. Before we thank them, a quick story. We did not discuss politics this morning.
Yay.
That is why the entire morning was filled with good information and civil. So I would like to think of the following before we go to lunch. A surgeon, an engineer, and a politician were in an argument. And in the argument, they were discussing which of them was the first mentioned in the Bible. The surgeon said, Adam, the rib, Eve, surgical procedure, medicine, first mentioned in the Bible. The engineer said, wait a minute. God created the world out of chaos in 6 days. Day, night, the building of the world. It's a feat of engineering. Clearly, God is an engineer. Engineering is the first profession referenced in the Bible. The two looked at the politician. He said, who do you think created the chaos? Thank the panel. We're going to go have lunch.
Okay, just a reminder for lunch, we have a wonderful... We will start the afternoon session. Okay, so we will begin the afternoon session. For those of you that were with us this morning, welcome back. For those of you that are just joining us now after lunch, welcome. My name is Greg Smogard. I'm Innovation and Business Development Officer with the University of South Florida, Sarasota-Manatee. I'm going to lightly moderate the afternoon session. But before we do that, just one housekeeping issue. First of all, I hope everybody was well fed and you are ready to go. I hope we'll have coffee here and can have coffee during the afternoon. I wanted to highlight one thing. I know there are several people that asked about slides, and I announced it this morning that we have everybody's email. We'll send out an email as a follow-up to the meeting, and there'll be a link to all of the slides. So if you're interested, there'll be a spot where you can go to gather that information. Just a quick summary, I think, for those of you that were here this morning, knew pretty much what happened. For those of you that weren't, we had, I think, a fantastic presentation with some excellent speakers and a panel. The theme of the day, of course, as you know, adapting to climate change, and the whole idea was to start at a very global level and work down to the community level. And this morning, I think we had great presentations regarding great data, great analysis, fabulous slideshows, and I think that they were presented, and from what I'm hearing, and for me as well, they were presented in a very compelling and easy to understand manner. So I wanted to thank the presenters. Sometimes this can get very complicated and you can kind of, your eyes glass over and it becomes very hard to understand. But I think this morning, I again want to just congratulate all the presenters to really get us to this second part of it. And there was one other element I wanted to thank them for as well. My background is in business and entrepreneurship and investing, and so I know how the private sector looks at adapting to climate change and how the startup community looks at it. And for me, it's always been a very successful business model and business skill set is to be able to connect the dots. And this morning, we started to see how some of these dots get connected. And the theme of today is also this afternoon, we're going to continue to try to connect the dots and bring it down, like I said, from a very much of a macro perspective down to a micro perspective. So we have presenters, and we have an excellent group of presenters this afternoon as well. Everybody from the community perspective, to the business and private sector perspective, to the entrepreneurship perspective. So we're going to have a couple of speakers, and we're going to have a panel, and we should pretty much wrap up on time. So with that, I'm going to introduce our first speaker. And we're delighted to have Tom Harmer with us. And again, I'm not going to spend a lot of time with it because all the bios are in your folder, so you can see the bios. But he's going to give us pretty much of a hands-on perspective of somebody who's in the trenches and on the front lines of dealing with this. His background is, again, with the Sarasota County. He's currently manager for the town of Longboat Key. And I am familiar with that. I used to have a condo as well on Longboat Key, and so I love that area. I love this area, and so I'm anxious to hear from him as well. So without further ado, I will welcome Tom to the stage. Tom.
Thank you. Can everyone hear me okay? All right, great. This is a tough time slot, Bob. Welcome back from your lunch break. What a couple of tough acts to follow. And as the town manager of Longboat Key, I quickly learned that there's some residents in Longboat Key that have a lot of knowledge. And obviously, Mr. Bob Bunting is one of them. Lenny Landau is another one. And we have a very enriched community for a lot of different reasons that we'll talk about in just a minute. I do have to ask, though, before we get started, how many people in here are not scientists? Not a scientist. Good. Because I didn't understand everything that they covered this morning. I think I got 90% of it, but I just want to make sure I wasn't the only one that wasn't a scientist. And I'm not going to spend a lot of time on my bio, but I do want to say I've been in local government for a long time. I did spend 6 years in the private sector from 2006 to 2012, but I started in local government in 1978, so 41 years ago, all in Florida. But I was trained more in the emergency management and public safety field. I started out in my first 19 years was in the fire and emergency management, was a fire chief in the state. And then I became a city manager, county administrator, and last year the town manager for Longboat Key. I say that to say that when you think about sea level rise, it doesn't necessarily fit well into being my first job as a 911 dispatcher. When you're measured on how many seconds it takes you to answer a phone and dispatch a unit, to a firefighter who tries to arrive on 3 to 5 minutes and take care of the problem. And I've been on fires, the wildfires in 1998 in Florida lasted 40 days. That was a long incident. but I'm hearing like 8,000 years and 12,000 years and the next century. And so my emergency management public safety background, I can tell you, I struggle with that just a little bit. I just think that there's a little bit of learning curve there for me on how to be patient and strategic all at the same time. But I'm excited to tell you today, though, the town of Longboat Keys sea level rise plan is well in hand, and we are full steam ahead in the town of Longboat Key. What I want to touch on today, 5 things. One, I want to kind of put Longboat Key in context. How many people here live on Longboat Key? Okay, so we do have quite a few residents here. And most everyone else probably has heard of it or has been there or has family or friends that live there, et cetera. But I'll put a little bit of that in context. Why is sea level rise important to the town? I think that becomes pretty obvious for all of us. And then we are going through an assessment process. We just kind of completed step 1 last year. I'll talk briefly about that. And then what are we doing? And there's some, I would say, and this is a bad word in government in general, we're doing siloed things. But we're starting to get our arms around those and how they all come together. So I want to talk about some of the things that we're doing and then kind of where do we go from here. So I heard micro and I heard macro, and I think this is kind of a very micro front lines discussion from a local government standpoint of what we're doing about sea level rise and how we're kind of working that. And it can be a little bit isolated on our own as well. So again, context, we all know where Longboat Key is. It's right across the bay. It's an island. It's about 11 miles long. It's 4.5 square miles. Elevation it's lower on the north end than it is on the south end. In round numbers, it's around 2+ in some of the low areas on the north end and up to about 8 foot or so in certain places on the south end. And that creates challenges, obviously. We have about 7,000 year-round residents. It really picks up November through April, March. February, March tend to be peak, but we go well over 20,000 during peak of season. So it triples for us. And one thing that's a little bit unique about Longboat Key is we're in 2 counties. University Parkway, right out here, goes right across the bay as an imaginary line and cuts our town in half, which is really interesting because when we talk about things like planning, which is one of the things we're talking about here today, it gets to be a challenge. We're actually in 2 different regional planning councils. That's the dividing line. There's a regional planning council that's Sarasota County and south, and there's a regional planning council line from Manatee County that goes up north towards Tampa, and we're in the middle. We're in both, which can be challenging. That's just one of the challenges of being in 2 counties. Also, a lot of Longboat Key developed over time, but there was a lot of development in the 60s and 70s. And when you look at the number of insured structures, so flood insurance, insured structures, we're a barrier island, we're in a coastal flood zone, and we have a lot of properties that are what we call pre-firm. The flood insurance rate maps, the pre-firm, so going earlier than 1975, and those homes are typically built on grade. They're below what we now use as that base flood elevation, and it includes both our single-family homes and our condos. And depending on the elevation of the home and the finished floor level, those insurance rates can be quite high, and they continue to increase. And I think everyone believes they're going to continue to increase. There's some belief that Florida is being subsidized and that we should pay even more insurance. And so that does have an impact to us for our residents. It has an impact on the value of property. If you're looking at buying a house and the flood insurance costs are thousands of dollars a year, then you're going to be less willing to pay a certain amount for the house. And then also we all live on the island under that 50% rule of FEMA. So if you're going to renovate your structure, you can't put in more than 50% of the value of the building, not the land in the building, but just the building. Or if you do, you have to then bring it up to the current standard, which in many cases may require lifting the house, 10 or 12 feet, which is not an easy feat, or which technically means you have to rebuild the house. And so there's limited incentives for those type of properties currently. And so we live with that right now and trying to sort through that as one of our existing conditions. I do want to say I am from the government, so you know I'm here to help. And I really appreciate Bob saying that we're not going to talk about politics. So I think I have one or two slides that aren't politics, but we'll see what Bob does and if he gives me a dirty look. But we are from the government, so we are going to find a way to tax you. So if you think about that, so we can pay our bills and provide police and fire and public works and all those other things that we do. So if we lose our roads, there may be another way that we can access revenue off of that. So why do people come to Longboat Key? You know, I think it's pretty obvious. I lived in downtown Sarasota. I was the county administrator in Sarasota County. And how do you turn down a job in Longboat Key? But I used to go to the beach at Longboat Key. Now I moved, a couple weeks ago, I moved into a house on Longboat Key. So I now have flood insurance. But I also have a beach like that. And it's worth that investment to everyone that's out there. You heard Lenny call this paradise. But that's why we get a lot of visitors. That's why we get visitors that turn into recurring visitors. That's why we get part-time residents, and that's why we end up with a lot of full-time residents, is because of the quality of life out there and the scenery and the beach. You know, if you think about Longboat Key, it's kind of interesting when you look at some of the numbers, and these are just some of the numbers, but the tax base in Longboat Key is $5.7 billion. That's on a skinny little island that's less than 11 miles long. The tax base is almost $6 billion. That's more than the city of Venice on that one little spit of land. That means revenue, too, for the local governments. And so I added Manatee and Sarasota together because we are split. But the total revenue annually that goes to county government is over $25 million. That's specific to county government. We also, our residents pay school taxes as part of their tax bill. Over almost $43 million a year goes to school boards. How many students do you think we have on Longboat Key? I actually know the number. It's about 75. So we get a pretty good deal. We could probably buy them all Mercedes and drive them to school, or have teachers come out and visit with us out there on Longboat Key. But the town has been very supportive of the school systems and hasn't been afraid to vote. They usually vote 70% plus when there's a school referendum on improvements to the school board. So it's a supportive donor community that recognizes that, but it is a big economic engine to government outside of just the town. And so just wanted to mention that. Property values we talked about already. Public infrastructure, just like houses, you know, we have infrastructure that traditionally was built on grade, and our lift stations that carry wastewater are typically built on grade, and all those things can be impacted by rising seas and high tidal conditions and things like that. So that's important. The impact on businesses, and what does that mean or do? And the private infrastructure as well, like seawalls and other private infrastructure. Interesting, I learned this over the past year. I've been in Longboat Key for a year now, but we just went to the market twice this year to borrow money. One, to build a new fire station, and number two, to underground all the utilities, every aerial utility. So cable, phone, electric is all going to be underground. It's about a $49 million project. But we just went to market to borrow for those two projects in two different series. And in doing that, I had a chance to spend a lot of time with S&P, Standard & Poor's, and they were very, 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 much more than I thought they'd be, very, very, very interested in what are you doing with sea level rise. Both rating exercises and rating calls, they spent a fair amount of time saying, well, help us understand, what are your conditions there now? What are you doing about it? When's the last time you assessed? What are you doing to plan? And then we mentioned that we just completed our initial assessment. And we were talking about, we just had a big public presentation before the town commission, and they said, oh, wow, can you send us that link? We want to watch that video. And so they ended up watching the video, and they gave us very positive feedback, and they also rated us an AA+, which there's 10 rating scales and institutional ratings, and AAA is the highest, AA+ is the second highest. So we actually jumped up 2 credit ratings this year with those borrows. But clearly, the rating agencies are interested in sea level rise. They made that very clear, which I found helpful and interesting. So we also, I mentioned, are in this assessment process. It's a 4-step process we laid out. The initial assessment is complete, and I'll talk about that. I've got a couple of slides I want to show. And then we have 3 steps that we're working on as the follow-up to that. But we got a lot of good information out of the initial assessment that I think helps us, so we're not waiting for the rest of it. But one of the things that's really important to the town, and I have to say that I have the mayor sitting here and the vice mayor sitting over there that are watching me closely. But one of the things that was really important to the town and the commission was that we be fact-based. You know, because this just happens to be one of those topics that there's a lot of things out there, noise out there about. And so we really did focus on facts-based. You can still be criticized even when you do that. Are you doing too much? Are you not doing enough? Are you moving too slow? Are you moving too fast? We know there's going to be people that have diverse opinions. And I thought it was interesting when I was thinking about crisis, because I was an emergency manager, I was a fire chief, I was a 911 dispatcher, I was a firefighter. And John F. Kennedy talked about crisis, and he used the example of Chinese kanji and the 2 symbols, where the first one means danger and the second one means opportunity. Now, you know, I was researching that, and I found there's a lot of controversy regarding his interpretation. They said it's not accurate. The second, and the screen went out, but I don't know why. The second kanji, though, really, if it's not opportunity, it still means that you're at a crucial point. And I think this is one of those things we're talking about. We're at a crucial point in a local government standpoint, and we're also at a crucial point when you look more globally and at a macro level. I wanted to share, I don't think this is political, Bob, but I wanted to share, this was a letter to the newspaper, and I didn't put a person's name on it for good reason, but this was actually verbatim when we said we were going to do an assessment for sea level rise on the island. And I just highlighted a few words. Okay, good. Well, and we're not saying, so this is a kind of, if you're local government, this is kind of the things that you just have to work with. But stunning was a word, that this would be a top priority of town management. Truly stunning logic, herd mentality, mass hysteria, jump on the wagon dynamic, very seductive, combustible psychology. We need to keep rising seas in realistic context. Let us be careful. But our commissioners have been very much in a leadership role and a supportive role of we need to plan, we need to do what we're doing. But you're always going to have, this is America. We obviously can read the newspaper or Twitter every day, and there's difference of opinions out there. We have difference of opinions on the key about should we really be spending money to pay attention to sea level rise? Don't we have more important things like potholes and new fire stations and sidewalks that need to be replaced and all those other things that are part of what we do on a day-to-day basis? And so that's just reality. We do that. And I think the bottom line on the letter was let's be careful. And I do think we do need to be careful and thoughtful and realistic and fact-based when we do this. But also, these are real pictures of Longboat Key. On the north end, some of that can be related to storms coming in, but also, I took the center picture myself, but that was not a storm event. That was a high tide. It was a king tide, high tide, and what happens is the water backs up into the stormwater system. So the stormwater system is designed for the water to flow out, but when the bay gets to a certain point, it pushes the water right up into the town. That is the north end of the key, which is the low, yeah. Yes, sir. And you'll see, I'll put an area up and you'll see that kind of area in just a second. So we do get street flooding on king tide scenarios. When we've had the Hurricane Michaels kind of go by and not hit us directly, we've had high tide situations that also created some localized flooding. Most of the time we don't get it in the buildings, but we do have street flooding. We do have, that's our town dock on the north end, and it comes in primarily from the stormwater system and some of our lowest areas where it can come right over seawalls, et cetera. And I'll just show you a couple of quick images. This is showing, and you may be able to see the light blue over the green. That's an area that would have water on it if we had a foot above normal high tide. And then I can show you, so that's a 2 foot above high tide. So if you think about a major storm event and you get a storm surge on top of, say, a high tide condition, that's 2 foot. If you go to 3 foot, you can see, and again, that's the north end of the town of Longboat Key. And that's our lowest area where we have most of the flooding concerns. We also, though, as you get to Mid-Key, we also have some other low areas that experience flooding as well. And so it varies a bit in the town, but there's an example of, you can see a 1, 2, 3 foot difference. And we were talking about out to 2,100, and that could be up to 2 meters, you know, so you say 6 feet in round numbers. This is about a 3 foot increase. Fortunately, it's not 2,100. So when we worked with our consultant on our assessment, we focused on localized data, localized historical data. And in this graph, this is over a period of 70 some years, and the sea level as measured in St. Petersburg. So it's as local as we could find over a historical consistent period. And you can see that that rose less than 8 inches. And so we then took that, and that's a little over 1/10 of an inch a year, historically going back over 70 years. Not too bad if it stayed on that same trend line. And then with our consultant, we looked at a couple things. One was we wanted to kind of figure out what's the right horizon. Should we be looking out to 2100? Should we be looking out to 2075, 2050, 2030? What's the right time horizon for us to look at from an immediate planning standpoint so that we're thinking about it today? And then we also looked at all the models. It's kind of like when I think of Bob, I think of spaghetti models. But all the hurricane spaghetti models, when you see all those models and you see 30 different ways that the storm could go, we also looked at that from the projections for sea level rise, what the trend line would be if it stayed the same, and then all the projections. And you can see on the one chart, it's a really wide range. After a lot of discussion, we kind of narrowed it down, and we went with the Army Corps one, and we took the best case and worst case scenario, and we decided that we should look out to 2050, which is a little over 30 years. And most infrastructure you put in, 30 years is a pretty reasonable expectation for useful life. And so when we did that, we came up with a range of about 7 inches to 17 inches as what our range could be if we look out to that time frame. And we're trying to use that when we then look out and do what we're doing with our infrastructure or thinking about private infrastructure. In addition to sea level, we also looked at storm surge and wanted to understand historically, has there been a change in storm surge severity over a historical time period? And so we looked back almost 40 years of records, and you could see that there were 42 events that exceeded what we set a threshold of a certain, I can't see that, but is it 2.5? Yeah, sorry, 2.5 feet. So you can see historically over that time frame where they occurred. And it is a little more frequent than it used to be. It's not overwhelmingly, but it is a little bit more frequent when you look and see the red dots. And those red dots are those that are higher than that 2.5 feet. We did then the same kind of a scenario with rainfall. We looked at daily rainfall, again, all this local from Bradenton, and we looked at it from the region. And the one chart on daily, obviously everyday rainfall, we set a threshold amount, and you can see the red dots for that. That's over 3 inches of rain in a day. And then we looked at on a monthly basis, any month that had more than 10 inches, and they were marked. And again, we're trying to see what's happening. Is it happening more frequently and to a greater severe extent? And you can see some of that. There is, in more recent history, some higher numbers. In some areas, it's not totally conclusive. Again, I'm not the scientist in the room. I did have to pass a couple of calculus classes because my degree does say engineering on it, but it's engineering technology, so they made me take calculus, but I'm not a scientist. So anyway, bottom line, our consultants, we had some public outreach, we had public meetings, we took input, we had meetings with the commission. They really said that sea level rise has been rising at a manageable rate historically. Sea level rise is going to continue to happen, and it's going to be higher. They said slightly higher, and they're talking about the near term, on the near term. If you look at the curve goes up, so over time, it potentially could accelerate at a greater extent. And they said we should use near term to evaluate, and near term to them was 2050 versus, say, 2021. And so it also weighed in on storm surge and rainfall and other things. And then as part of their conclusions, they did say that we looked at the town's infrastructure, and you should feel pretty good that you've mitigated a lot of concerns. And I'll show you a slide in a second that touches on why they think that. They did say you do have some areas of concern. There is a lot more work you need to do, but you're in a pretty good spot as long as you start working on it incrementally now. So that's kind of the way we left our initial assessment. So what are we doing? You know, we are in a pretty good position with our facilities. If you think about the public facilities like our town hall and our police station and our fire stations, we're replacing one of our fire stations this year. Our major lift stations, we're all pretty good because they were developed post-firm, so after the mid-1970s. And that means that they were built up higher and have some ability to survive and significant flooding. We also, in the town, increased the base flood elevation. We added a foot to that in our planning, and it's maybe something we consider again as we now have this new assessment information. The commission this past year increased private seawall height. They said they raised it up 18 inches. So if you think 18 inches, well, we just said it's 7 inches to 17 inches is our forecast. They've added the ability for private owners to go up an additional 18 inches in their seawalls. That's kind of an opportunity for those that are putting in new seawalls, replacing seawalls, to add a little bit of height. We did the third-party assessment. We're still working through the next phase on that. We do have concerns about stormwater. I showed you some of the conditions there. And then we have a number of other things we're just working on, to me, that they all start to pull together. Our beach management plan, designing the new fire station. What is the finished floor level with that? We're implementing new stormwater valves that are different than the traditional valves. I'll show you that in just a minute. And we're also working on some hardening on the north end. So here's a couple images of town facilities. Again, you can see they factored that in. They're built up to address those concerns. Our public works facility, our town hall, our tennis center, that's one of our major lift stations. But we have this stormwater infrastructure, and you can see in the roadway, you can see the stormwater grate there that's underwater. That's where the water's coming from. And one of the things that's challenging is, and a lot of communities have this, they're called duckbill valves. And the water goes out those when they fill up, but they look kind of like a duckbill. But what happens is debris goes down your stormwater drain during a storm, twigs and branches and trash and everything else, and it can get stuck as it comes out, so they don't ever close completely because of that. And over time, it's even harder for them to close up and seal, so as the tide rises, it just runs back up into the system and it can back up into the streets. So there are some new valves out there that have been developed over the last couple of years. We were installing some. We have some in place now. We just installed 3 in the north end in what we call the village area. We just bought 10 new valves. We're installing another 7 of them, and then we'll be buying another batch behind those. And these valves do a much better job of allowing just one way of flow versus that opportunity to get the backflow into the system. So that's another thing that we're working on. I wasn't going to talk a lot about beach nourishment, but obviously it's a big deal to the town. We have engineered beaches. We've been maintaining them for years. It costs millions of dollars to maintain those beaches, but it's critical for the town. I showed you the picture of why people come here. This was taken right after Hurricane Michael. And the bottom picture on the right, I think, is interesting. You know, the island moves around a little bit. And so here's an example of, we had loss areas. We lost sand. It just seemed to disappear. But then there were other areas where you can see the chairs. The day before, the chairs were on top of the sand. After the storm came through, they were under the sand. The beach had extended. So we have this condition where the sand will move around a little bit. We'll lose some, and sand naturally goes north to south mostly in the state and on the Gulf Coast. But we do get these areas where pick up more sand in the process. One of the projects that I know Bob is interested in is the hardening of the north end. And one of the things that's a challenge there is there's a pass there. This is in between Bradenton Beach and Longboat Key. And whenever you have a pass, you get sand that moves into the pass too. But we also have a southerly draw of sand as well. And so that becomes an area of conflict. And one of the things the town's doing is working on hardening that. So we're talking to the state. It's an active project to build some structures there that will allow us to protect the properties that are there and also help minimize the sand replacement, or at least reduce that, because it's a significant cost. Sand is extremely expensive, and it's hard to find the source. And if you can't get it close offshore, you end up having to buy it somewhere else, and it's even more expensive. So where do we go from here? We really want to take a strategic approach. We think we have a lot of things that we've done historically, and we know we're active in the planning stage, and we're building a new fire station, and we're implementing new valves, and we want to kind of pull that into a shoreline protection plan so that it's a more unified approach. We really have information now. I talked about that 2050 horizon in 7 to 17 inches that we can start using in our capital budget process and help us prioritize projects as we're using our limited resources to help pay for that. We're going to continue on with the assessment process as we go along. We have a priority with the town. We list each year our legislative priorities that we send to the state and the state elected officials, the representatives and the senators. And sea level rise is on our list. It's been on our list, but it's on our list. The mayor is actually going to be Monday presenting our list to the local delegation here in Sarasota County, and the vice mayor presented it a few weeks ago to Manatee County local delegation. So we're trying to figure out how do we get legislative support, because on the front lines, some of these improvements can be pretty significant. Even the planning process can be pretty costly to the town. There's communities out there that are spending $300,000, $400,000, $500,000 to go through an assessment and implementation plan strategy. So if we can do more together and spread those costs out, it would be helpful for everyone. So we're looking for some of that support. We're looking for regional opportunities to share information and data. And just like Red Tide, you heard the discussion about there really needs to be some statewide leadership on Red Tide. The same thing I think applies to sea level rise. We really need leadership because there's all these things that are going on. How do we help as members of the public, as residents, as local governments, as businesses, as academia? How do we help get that where there's whether it's a single center or some other presence that provides leadership and helps pull things together? And I think that applies to both Red Tide and sea level rise. So that's kind of where we're at. That's what we're doing. I'd be happy to answer any questions depending on how much time I have left. Okay, good.
What is likely to be your approach in dealing with the issue of takings?
Of takings? Well, yeah, I can tell you takings are very difficult because, and so everyone knows what a taking is? Okay. So a taking would be you want to take someone's private property from them and use it for public purpose. So if I came to you and said, I really would rather use your piece of property for a stormwater pond, and you say no, I say, okay, well, I'll just take it. So that's a taking. A taking is not that exciting for a town commission or a city commission because of private property rights and trying to understand that. So I think takings are last resorts. And you try not to do that unless it's extremely, extremely critical and there's no other choice for the community. And when you do a taking, you have to pay fair market value for that. And that can be determined in a very expensive way through the court process.
Does that also apply to the issue of, let's say you designate an area as likely to be inundated, and then that property value drops?
Yeah.
Someone argue that in itself is a form of takings.
Yep, they could, and we'd probably end up in court over that one, and there would be someone else that would decide that. But I think the town needs to have an action plan, and they needs to make incremental progress. And like in our north end, where we do get flooding, right now we're doing valves, but in 10 or 15 or 20 years, we might need to be talking about pumps. And then after that, we might need to be talking about something else. But also, what happens with FEMA and the National Flood Insurance Program and recurring loss properties. So we have recurring loss properties in the town, less than 100 of them, but they've had multiple losses due to flooding or storm events, and they keep getting money through the insurance program. I think there's going to be action to try and minimize those recurring properties as well. So I think our responsibility is to have a plan and incrementally move forward with it. Here and then here. Yes, sir.
from reading the Herald Tribune's continuing stories on record prices paid for houses on Longboat Key, I take it that the threat of sea level rise hasn't yet affected property values. Do you and your commission have a point in mind when that might begin to happen, and how you will react to that reduced revenue if it occurs, when it will occur?
And there's not a bright line. There's not a bright line that says when it gets to this point. I think the market kind of goes up and down, and we all know that we've been in a growing market for 8 or 10 years now, and a growing economy. We're anticipating there'll be some flattening of that, trying to figure out how much of that would be related to sea level rise versus the economy in general is sometimes hard. But I'm sure we have isolated cases already that someone has been out there looking for a house and they came out on a rainy day or a high tide day and said, maybe I don't want to live here, I want to live there. So I think we have anecdotal evidence. We don't have a bright line. I think we work with the property appraisers each year on our evaluations in the town and the increases or decreases in that. And with our planning, that was one of the items that was identified by our consultant to kind of do some more work on.
Very impressive and excellent presentation and great plan, especially on the short-term horizon, 30 years or so. And that's very good because in the long run, we'll be all dead anyway. And we can leave behind the problem for future generations. But I think that there are other communities that are addressing it. As you know, yes. Miami has a very, very active program. Yep. They're looking at some of the pumps, yep. and Netherlands as well, and other parts of the community, other countries, other part of the state. So that brings me to the one of the very first slide that you had is crisis equals to yes. opportunity. Yes. So where do you see the opportunity? How do you build a better future so that not only your community thrive, but also others can benefit from it?
Yeah, I think that's a good question. And one of the things that we're trying to do is learn from others. I think that's always helpful. The Florida League of Cities at their conference this year had a presentation on what they're doing down in Miami, and there's a compact of 3 counties down there, Dade, Broward, and Palm Beach, and they've all gotten together to plan and to forecast, and they've come up with a unified approach to what the forecast is. So what is our best and worst case scenario? Because you could take that range and say it's 6 meters, or you could say it's 6 inches. And so they've agreed to a 3-county approach to what is the best and worst case, and then let's plan to that. And then they're looking for grants together to help pay for infrastructure. They're doing joint planning. They're hiring consultants to help on a regional basis and spreading it out. I think that's a good idea of how you jointly plan. I think we've got to do we've got to have a near-term piece of our brain and a strategic long-term piece of our brain. As we're incrementally implementing this, I think we're focusing first on the near term, the next 30 years to 2050. And then while we're doing that over the next year or two with the rest of our assessment, we can build in a longer-term plan.
My question fits nicely into what you just said. What kind of collaborative work are you doing with your neighboring barrier island communities?
Yes, I know Stevie's here, and she's going to be talking or on a panel coming up, but I think we've just started that process. I think it's important to understand. I know we know what the city of Sarasota is doing, and they've been active in putting their plan together. I think one of the things that we learned about this is it's been siloed, and everyone's doing a little bit of their own thing. So we're trying to pick up on what people are doing around us, but at the same time, we didn't want to wait. So that's why we brought in our own consultant and said, let's look at local data. Let's figure out what we should be focusing on. But I do think as we go forward, that outreach is going to be important, especially looking for economies of scale.
Also, I'd like to say that I live on Longboat Key. And so over the last, I'd say 6 or 7 years, I think I've been in front of our town commission at least a dozen times. And talking about these very things. And over time, it may not seem like things are changing, but my own assessment now is that Longboat Key is progressive. They realize they have a $6 billion tax base and that it's subject to go down if they're not progressive about managing the beaches in an age of sea level rise, which is a climate change result. And when you see Tom talking about stabilizing the north end, we've been working on that for at least a half a dozen years, and gradually it's happening. So it may not be as fast as we all like, but over time it really makes a big difference. And I think the vision that is on Longboat Key now about how to deal with these things, how to integrate with other communities, you're hearing all this kind of stuff that you don't hear anyplace else. So I'd like to think they're creating a sea-safe community to the extent that you can. There's no reason people have to retreat if they do the right things, but you can't do it overnight. You have to plan, it has to be implemented over time, and it has to be done in a way that's cost-effective. And so I'd like to applaud Tom in particular, because he's brought it a long way in a short amount of time, and also some of our guests here who are on the commission, including our mayor, who's done a great job in bringing this forward. But it's just another example of how you get out of the silo approach and start getting into an integrated solution. And that's what adaptation is all about.
And I would just say, I was just going to say, from a manager standpoint, and I've been a local government manager since 1999, so 20 years in 3 different communities, we have a lot of things that we deal with. Like I mentioned before, whether it's sidewalks or potholes or power lines or water or sewer or fire or EMS transport or law enforcement or coyotes or all these other things that we're dealing with. And sea level rise can get lost in that because it's not immediate. But I do think our commission recognizes how important it is. And so it's been easy from my standpoint coming in last year for us to keep moving forward. Because you see those buildings I showed you, they've been built over the last 10, 15 years, 20 years maybe, and some of them that were built to a higher standard, knowing that investment was okay to prepare long term. Yes, sir.
Bravo. I snowbird, and my home state is Massachusetts, with a history of town meetings, pure democratic things. So I'm curious, and perhaps Bob and maybe the mayor and you, Tom, can answer the question about the governance processes that you all had that got you to this point.
Yeah, and I can only go back to the last year personally. So if the mayor or the vice mayor want to weigh in, I can just tell you what I found coming over from Sarasota County is, number one, in Longboat Key, we have some really educated population. We have, Bob Bunting has my cell phone number and calls me regularly. Lenny and I have talked and met in my office a number of times. And that's just 2 of 100 members of the community that, are either engineers, scientists, former COOs, CEOs, CFOs that have a lot of experience, marketing experience, you name it, all their economic development experience. And they come in and then they go to commission meetings and they give feedback. And the mayor could tell you about, there's a revitalization task force that was formed a number of years ago that he put together that is not sanctioned by the town, but that group, and Lenny's involved in that group advances issues like red tide and sea level rise. And they do that together on their own, and then they come to the town commission and pitch it, and they brief the town staff and pitch it. So because of that work behind the scenes, it's made the staff's job easy. When we've said, hey, we'd like to advance it this way, and the commission said, good, we agree, go do it. And again, we have 4 of the 7 commissioners are attorneys, not that that's good or bad. We have a mayor who's an MIT grad, our vice mayor is an attorney here. We have an architect planner, so we have a mix of highly intelligent, successful individuals that like to debate and advance. They like to see progress. So. Well, I feel very blessed to be on Longboat Key, and I was very blessed when the commission asked me if I would join the team. So,
yeah, thanks for your presentation. I guess everything I think we heard about has to do with adaptation, and a big focus on investment and adaptation. So I guess what I'm wondering is, how much are you guys talking about avoidance and incentivizing or requiring changes so that you're actually avoiding the increase in greenhouse gas emissions, because there hasn't really been any discussion about that. And it is a trade-off between investing in adaptation or investing in avoidance. And at some point, we won't be able to adapt anymore. And I don't think, for example, I don't think Longboat Key will be able to adapt to 6 feet.
Yes, no, I understand. My house, my property that I just moved out there on is 5.7 feet. So I agree with you that 6 foot. Now my finished floor level is at 14.7, but I have to take a boat to my property if it got to 6 feet. So that's true, and I think that's a good question. And we heard, like with red tide and fertilizer, you know, Sarasota County has a fertilizer ordinance that goes beyond the state law, and they're grandfathered in. And so the only way they can do that is because they're grandfathered in. They can't implement harsher or more severe regulations because the state has preempted them. And so that's something to talk about legislatively. We've adopted the same standards as Sarasota County, so we're as restrictive as we can be on things like that. Our facilities with sustainability in mind and greenhouse gases and things like that, you know, we're going to build sustainable buildings. You know, that's one way. But we also need to look at a number of other things. We're taking the incremental approach. We're taking kind of one step at a time. We don't have an end product here to talk to you about today. We can just tell you that we're on the journey and we're making progress and we feel good about it. But I think that's on the plate. What do we do with that? And what's within our control? And what can we lobby for that's outside of our control? And how can we participate in the process?
Okay, I think we have time for one more.
Okay.
So.
In the interest of building an educated public opinion, has there been attention given to building curriculums from minor, the youngest children up to university? It just seems like if you want to build the future, you're going to educate people.
I think that's an excellent idea. How do you educate and get people more aware? Because this is a long-term issue.
Right.
We, with our 75 students, we have not taken that on. And we're not responsible for the school board, but I think that's a great idea, and anything we could do to help share that message would be, because I think, you know, I came up as a firefighter. Stop, drop, and roll. Get into the schools. Teach them early. Let them go home and tell their parents on what that means. That's right. You get both generations through the kids. So I think that's an excellent idea. Yeah.
All right, Tom, thank you very much.
Thank you. Thank you.